All right, guys, today we're going to start a new unit where we're going to be solving exponential equations. Now recall, exponential equations were one of the most important things in terms of real-world applications that we've seen so far this year. Money grows exponentially, things in nature grow exponentially, things decay exponentially, and we started to explore them, but we didn't have the ability to solve these equations as well as we needed to. And that was the reason we went and learned about logs, is because they help us with exponentials. So today we're going to put together our knowledge of logs and our ability to do things with, our desire to do things with exponentials. And we're going to go solve exponential equations. So I hope you're excited for today. I know I am. What we're going to use is an important property of logarithms in order to solve this. If you have log base a of a to the x, recall what a logarithm is asking. This is saying a to what power gives you a to the x. And as long as the base of the log and the base of the exponential are the same, the answer will be a to what power gives you a to the x. The answer will be x. This is a fundamental property of logarithms that will always be true. If you have an exponential and you do a log base with the same base of that exponential, the log and the exponential will kind of cancel out, is a good way to think about it. And you'll just get x. These are inverse operations. They cancel each other out. And we're going to use this property to solve exponentials. But to be able to use this property, we need, so this is like an important property. This is the key thing. To be able to use it, we need an exponential by itself. An exponential isolated means by itself. And the way this looks is if you have something like a to the x equals b, then we're going to be able to solve it. And the way we're going to do it is we're going to do the same thing to both sides of the equation. What we'll do is we'll do log base a, whatever the base of the exponential is, we'll do the log on the left side. And if we do it to the left side, we will also do it to the right side. So this is what this will look like. We'll do the log on both sides. And on this side, the log will cancel out, and we'll find out what x is. So this is how we'll be able to solve for a variable we want to have. Let's see how this looks. Let's do an example, and then I'll let you do a lot of practice today. All right, this first one, this is not an isolated exponential. And so we can't yet use our inverse log equations. What we're going to do is we're going to first isolate the exponential so we can use the trick we just did. And this is going to use exponential. It's hard to talk and spell, it turns out. This is going to use your Algebra 1 skills, where, here is our exponential, 3 to the x. We always want something to the something power. That's going to be what we try to get by ourselves. And solving this is going to look a whole lot like if we were solving the equation 2x plus 1 equals 37, because we're trying to get this exponential by itself. That's like our x we're trying to get by ourselves. And so I hope we remember from Algebra 1, our first step here should be what? Well, we want to subtract 1. We're undoing the operations, and just like log is the inverse of exponential, subtracting is the inverse of adding. And so we get 2 times 3 to the x equals 36. Now we can divide by 2. Because dividing by 2, we still haven't gotten this exponential by itself, and the exponential is getting multiplied by 2. So we're going to divide by 2. And in this case, we've now gotten the exponential by itself, and the last step will be to do the logarithm with that base on the same side. This is 3 to the x, so we need to do log with what base? This has to be log base 3. On both sides. So log base 3 on both sides. That will cancel this out. And sometimes we'll be able to evaluate 3 to what power gets you 18? Well, 3 to the 1 power is 3. 3 squared is 9. 3 times 3 times 3 is 27. This one actually doesn't come out to be a rational number. And we'll talk about this in just a little bit while, but it's okay to leave things as irrational numbers. However, the first part of your practice today will all involve getting like numbers out that you can evaluate. But if we have to leave an answer like this is okay. We know this is 2 point something because 3 squared is 9 and 3 cubed is 27. We know it's 2 point something, but this is the irrational answer. It's kind of like leaving something as square root of 5. You know, we know square root of 5 is a little bit bigger than 2, but we don't know exactly how big it is, and it's completely acceptable to leave an irrational number in this way. And we'll talk about that later today. For now, though, I want you guys to practice some. Try to solve these on your own and try to solve them using logarithms. All right, why don't you start with number 1? 5 to the x equals 125. And I hope you notice that this exponential is isolated already. There's already just an exponential by itself. So we can just do log base 5 of both sides. So log base 5 of 5 to the x equals log base 5 of 125. 5 to what power gets you 5 to the x? Well, that's going to cancel out. The answer is just x. And here, 5 to what power gets you 125? And the answer is 3. And guys, I hope you can just see from the very beginning, like, this is answering what exponent goes up here. 5, this log question is just asking 5 to what power gets you 125. Did we need logs to be able to solve this super simple one? No, we didn't. But, you know, we can use them and it'll be just fine. Why don't you guys try this next one? 3 to the x equals 1/9. Hopefully you realize that you need to do log base 3 on both sides. So log base 3 of 3 to the x equals, you're doing the same thing to both sides. And we could do this because the exponential was already isolated. There's nothing here with this exponential. Okay, so that will cancel and we get x equals, we've got one of our special exponents. 3 to what power gets us 1/9? Hopefully we recognize that 3 to a negative power will be 1/9. If you haven't done lesson 8.1, you probably can't do a lot of the stuff we're doing here yet. You need logarithm stuff to be able to do this. That's why we learned about it first. How about this one? Try this one on your own. Also, here, hopefully you recognize that what we need to do is, here's the exponential. It's isolated. So we'll do log base 8 on both sides. So we'll do log base 8 on both sides. And notice when I'm writing it, I'll say this for everybody's sake in a second. So 8 to what power gets you 2? Well, this one's going down. This is one of those other special exponent ones. This one's a fraction. It's the 1/3 power. And here this cancels out. X is 1/3. And the reason it's the 1/3 power is that the cube root of 8, what times what times what times what equals 8? That's 2. And the cube root of 8, remember fraction exponents are roots. And so this works. Now, I'd like to point out to everybody how I'm writing it. Notice that the log is not lower down. I sometimes see kids doing like this, log base 2 of like 8 or something like this, where like this almost looks like an exponent. That's not quite right. Remember that the thing you're doing the log of, this is an operation. It's like doing square root of 8, right? When we're doing log base 2 of 8, the 8 is the same height as the log. It's the 2 that's lower down. It's like when we're doing square root of 8. We wouldn't do like square root to the 8th power. That's like not how we would write it. We would write square root and then the 8 inside of the square root. This is inside of the log. Okay, so just to make sure we're writing it well. Okay, let's look at another example. We'll do this one together. Notice this time there is an isolated exponential, but there's also another isolated exponential, and that's okay. We can just do log on both sides, and in this case, the base of the exponential is 5. We're just going to do log base 5 on both sides. I'm going to sneak it in here. And here, log base 5 will cancel out with 5 to the power of something. Log base 5 will cancel out with 5 to the power of something. And we'll get 10x plus 2 equals 3x minus 12. And we can solve this from here. Go ahead and try it on your own. Hopefully you notice that you can subtract 3x on both sides because there's more than one set of x's. This is a linear equation where we try to get all the x's on one side. And so we'll get 7x's. And there's also constants that we want to get to the other side of the, we also want the constants to be on the other side of the variables. So, oops, minus 2 minus 2. We'll subtract 2 on both sides, and we'll get negative 14. Last, 7 is multiplying times x, so we will divide by 7 and get x is negative 2. Now, this is a lot harder to see without logs, I think. So, how about this next one? Well, I hope we recognize that we have an exponential with x in it right here isolated. And so we want to do an exponential with this log with this base. And I hope we recognize that the right one to do is the natural log. That's a log base e. Natural log will cancel out an exponential with a base of e, because natural log is automatically e to the power, log base e of something. So here, the log and the exponential cancel out. We get 3x plus 2 equals natural log of e to the 8th is just 8. And we can solve this from here. We're going to subtract 2 to undo the adding, and we're going to divide by 3 to undo the multiplying, and x is 2. All right, let's see how you guys do in this one. Here, I hope we notice that the exponential is right here, and to isolate it, we need to add 2 to both sides first to get the exponential by itself so that we can use our new property. So we isolate the exponential. Now the exponential is by itself. It's 5 to some power, even though there's a bunch of stuff up here that's inside of the exponential. So we can do log base 5. Notice I'm trying to write log the same height as this and the 5 lower down. Here, this cancels it out. And here, 3x plus 4 equals 5 to what power gets you 125? Well, that's 3. 5 times 5 is 25. 25 times 5 is 125. And now we're at a linear equation where we're just trying to get the x's by itself. So there's a lot of algebra 1 skills going on today. And now we're dividing by 3. X is negative 1/3. Great. This next one, 7. To get the exponential by itself, we need to, it's multiplying by 2, so we divide by 2. Boop. 8 to the x power equals 64. And now we're going to take the log on both sides. So log base 8. Log base 8. Here that will cancel out. And on the other side, 8 to what power gets you 64? The answer is 2. Now, guys, I just want to bring this back. What are we doing every time? We're isolating an exponential, right? We need exponential that's isolated something to a power with x in it. And then we're doing log on both sides to cancel out the log that's already there. That's all we're doing every time. Let's just bring it back there. All right. Here, what should we do? Well, here's our exponential. We want to isolate it. So we're going to add 1 to both sides. It's 243 equals, I guess I should be writing this in blue. 243 equals 3 times 9 to the x. Here's our exponential. Keep in mind, we're trying to isolate this part, so it's getting multiplied by 3, so we divide by 3. 243 divided by 3, you may not know that off the top of your head, but I hope we know how to do, like, division, right? 3 goes into 2, it doesn't go into 2. 3 goes into 24 8 times. 8 times 3 is 24. That's 0, 3. 3 goes into 3 one time. 3 goes into 243 81 times, and that is 9 to the x. Oh, we should be able to do this without a calculator, guys. Here, log base 9 to get rid of the exponential. And this answer is 2. Now, the most common mistake, 9 squared gives you 2. The most common mistake some people have, and you may have already experienced this in this practice, is that sometimes, people will be like, oh, 9 to the x equals 81, and they'll just try to do something that is not true, which is like divide by 9. They'll be like, that cancels out. X equals 9. No, it doesn't, guys. Dividing does not cancel out exponentials. Those are not inverse functions. The way to cancel out an exponential is not dividing, and if you write that, you're lying. It doesn't cancel it out. Log base 9 will cancel out 9 to the x. So be careful with that. Okay. Here we go. Here is our exponential right here. Stop. Minus 5, minus 5. 5 times 10 to the 2x plus 1 equals 50,000. 10 to the 2x plus 1, again, that's our exponential. That's something to the power. It's getting multiplied by 5. So we are going to divide by 5. 10 to the 2x plus 1 equals 10,000. What log do we need to do here? Well, it's log base 10, and we don't usually write log base 10. We just write log on both sides because log is log base 10, and that will cancel out the 10 to the power of. So 2x plus 1 equals 10 to what power gets you this? Well, this is the 4th power, because you could just count the zeros when you're doing log. It's one of the easier things to do. Now we're going to subtract 1. I'm going to start doing these last 2 steps at once. We're going to subtract 1, that's 3, and divide by 2. So I hope we know our algebra 1. This is 3 halves. I subtracted 1 and divided by 2. 3 halves, or 1.5. I'm going to start doing that last step a little bit shorter if we keep doing it in the future. Okay, here. We've got a weird exponential, but it's still an exponential. We have 5 to some power. It's just that the power is weird. So we need to isolate this. Divide by 25. Divide by 25. 5 to the x squared plus 3x powers equals 1 over 25. We've got 5 to the power of something, so we undo it by doing log base 5. We always find our exponential and do log with that base on both sides. That's our new skill today. And now we have something a little bit different. 5 to what power gets you 1 over 25? That's one of our special exponents. It's -2. And we have something a little bit different here. Unlike before where we had linear equations where we're just isolating x, we now have a quadratic equation. And here we should be making one side equal to 0. That's how we solve quadratic equations. It's quite different. Don't just start like trying to isolate stuff when it's a different type of equation. And the reason we want to make it equal to 0 is because now we can factor. So go ahead and factor this one. Hopefully we can solve it from here. Here, we need to find 2 things that multiply to make 2. They multiply to make 2 that add to be 3. And those numbers are 2 and 1. 2 times 1 is 2, 2 plus 1 is 3, and so now we can see what x needs to be 0. Either one of these needs to equal 0, and so x needs to equal -2, because -2 plus 2 is 0, and x equals -1. We get 2 possible solutions for what the x could be that will make this exponential equation true. Last one of the day, try this one on your own. We're going to add 2. That's 27. Now we get our exponential, which is weird. Be careful. Make sure you're writing all of this carefully, that this is all in the exponent, because you can't subtract the 1 because it's in the exponent, right? If that 1 were a little bit lower down, it would look like you could subtract it, but you cannot because it is in the exponent. So 3 to what power gets us 27? Hopefully we're good at logs by now. I'm kind of assuming we are. Equals square root of 2x plus 7. Now the exponent is not in the exponential anymore, and we can do stuff with it. This is a square root equation, and so we can solve it by isolating the square root. And then what is the inverse of square roots? Well, hopefully we know that the inverse of square root is squaring something. So we're bringing back together some of our old tricks. I'm just going to use this space down here. I'm going to subtract 7. So 4 minus 7 is -3, and divide by 2. And I do need to go back to the beginning of the square root equation and plug this in to make sure it wasn't an extraneous solution. So let's do that. 2 times -3 halves is the multiplying by 2 and the divide. So what I'm doing here is I'm plugging in -3 halves plus 7 plus 1 to see, does this actually equal 3? I have to check it because it's a square root equation, and I'm going to go back to where the square root equation part was and check it to make sure it's not an extraneous solution. Multiplying by 2 and dividing by 2 cancel each other out. -3 plus 7 is 4, so square root of 4 plus 1 equals 3. Square root of 4 is 2, 2 plus 1 is 3, and so that does work. But we got to be a little careful on these other types of equations to remember what we were doing. Now, I want to briefly go back to what we talked about earlier. We said earlier that sometimes all the ones in our practice so far came out to be whole numbers when we did the log. However, that is not always the case. Sometimes logs come out to be irrational numbers. And I want to tell you need a calculator for the rest of this lesson. So go to our main blend page. There's a calculator icon. Hopefully you already have one, but if not, you can get one there. Any of the ones that I suggest will be fine. I'm going to talk about the ones we use in class. So to get to log, you press the math button. That's 2 below the blue button. It says math. You press it, and you press up twice. Math, up, up. And it'll say log base. Great. Now you just put in the log. Log base 3 of 18. And the answer is 2.6309. And it keeps going. It's an irrational number. This is about 2.631. We will, in this class, round to 3 decimal places. And you'll notice that, unless it's money, if it's money, we'll round to 2 decimal places because that's pennies. But you'll notice that it was 0.9 because that 9 was above 5, we round up. So you can round your answer to 3 decimal places, or in math, it's always acceptable to leave it as the exact answer. This is the exact irrational answer. And so sometimes we'll get irrational numbers, and that's okay. Okay. Try to solve these on your own, see what's going on here. You can, we do not need to put the decimals in these because they are not word problems. When we get to word problem ones, we will always put decimal answers, but in math, it's always okay to just leave it. So try to do this first one on your own. Well, this is an exponential with a base of 10, so we're going to do a log base of 10, which is just log. We don't need to put base 10 because it's automatically base 10. I hope you feel good about that. So x equals log of 12, and we leave it like this. This is a completely fine way to answer it, just log of 12. Sometimes we'll write log of 12 like that. That's also fine. And if you really want to, you can round it to 3 decimal places, but it's not necessary. Now, log base 10 is such a common one that it actually has its own button. You don't have to press math to go to it, although you could. You'll notice there's a log button here and an ln button here. This is the logarithm base 10. This is the natural log. So you can do log of 12, and you should notice that this is a little bit bigger than 1 even before pressing it, because 10 to the 1 power would be 10. 10 squared would be 100, and so this is 1.079. So feel free to leave it like this or put 1.079. All right. How about this next one? Go ahead and solve it. Well, you get 8 to the x plus 4, you add 1 to both sides, is 13, and now we can do log base 8. Now, just like with square roots, sometimes you're going to be asked to do operations with them. Here we need to subtract 4. X equals log base 8 of 13 minus 4. Because we had to subtract both sides. Now, I'm going to put parentheses here to show that the minus 4 is not in the logarithm. We're doing log base 8 of 13. It's like putting square root of 13 minus 4. You can't combine these. One is inside the square root and the other one's not. One is inside the logarithm and the other one is not. And so this is the simplified answer. Log base 8 of 13 minus 4. Now, again, could we get it as a decimal? Yes, but you want to wait till the end to plug it in. Otherwise, you're going to lose some accuracy. So we want to type it in like this. So remember how we get to it. We press math, up, log base 8 of 13. I guess I should have, hold on. Log base 8 of 13, close the logarithm to make sure it's ended, minus 4. Notice that if I did, if I deleted, hold on, math, up, it won't let me do this. Log base 8 of 13 minus 4, this will come out very different and it will be wrong. So we can leave the answer like this, or we can put negative 2.767. The last number is a 6, but the one after that is a 5, and so on. So we'll round to 3 decimal places today. Okay, how about this one? What do you do? Well, hopefully you recognize you subtract 4 and get 11, and then we have to do a log base e. That is the natural log, and that'll cancel out. 2x minus 3 equals, we just leave it as natural log of 11. E to what power gets you 11? We leave it. Then we add 3. When I'm writing this, I need to put the 11 in parentheses to make sure it's clear that the 3 is not inside the logarithm. Here I didn't write the parentheses because there's nothing after it, but here I do need to. You're doing e to what power gets you 11, not e to what power gets you 11 plus 3. You're doing e to what power gets you 11 and then adding 3. And so we show that by doing it. Now, to divide everything by 2, we need to put a bar over the whole thing and put divided by 2. And this is how we would leave our answer. If we're typing this into play posit or something, we would type natural log of 11 plus 3. We would use parentheses to show this. And this whole thing would be in parentheses being divided by 2. And we would put parentheses here to show that the whole binomial is being divided by 2. If you didn't put parentheses, it would be like adding 3 halves. So if you put natural log of 11 plus 3 divided by 2 with no parentheses, only the 3 would be getting divided by 2. That's not right. Okay. I think we're going to stop on these and let's go to some word problems real quick. All right. Okay. The function that represents the value of an investment is given by v equals 5,000. This must have been the starting amount times 10 to the t over 5. This means it's going up by 10 times every 5 years. How long will it take for the investment to reach $500,000? Well, let's solve this. We want the value of the investment to reach $500,000. Is that the time? No, that's the value. So we're going to put $500,000 equals 5,000 times 10 to the t over 5. Go ahead and solve this one on your own. Well, hopefully we recognize we want to get the exponential by itself. The exponential is getting multiplied by 5,000, so we divide by 5,000. Let's see. 5 divided by 5 will be 1, and we'll just cancel out zeros. I hope you guys know this trick of dividing. You just cancel out the right number of zeros. So 100 equals 10 to the t over 5. We now have an exponential that's isolated, 10 to some power. So we do a log with a base of 10. And we don't have to write log base 10 because it's automatically base 10 if we don't write it. So 10 to what power gets you 100? 2. Equals t over 5. And the last step of dividing t by 5 to undo dividing by 5, we multiply by 5. So hopefully we feel good about we've been doing a lot of algebra 1 steps today. So the answer is 10. We should put units with this. This is years. How many years will it take? Let's answer in years. T equals 10 years. Okay. You do need a calculator on these last 4 problems, and you will use it and you will round. Martha invests $3,000 in an account earning 5% annual interest. How long will it take for the account to be worth $10,000? I hope we can see these were questions we couldn't answer before when we were doing our exponentials unit, but now we can. So start by, how do you write the equation for the function that will show Martha investing $3,000 and investing 5% annual interest? Hopefully remember that the amount is going to equal the starting amount times it's 5% annual interest. It's just 5% at the end of every year. So we'll be multiplying by 1 to get her back to how much she had. Plus, we need to add in 5% to get her to go up by 5% each year. So A equals 3,000 times 1.05 to the t. And go ahead and solve it. How long will it take for this account to be worth $10,000? Well, $10,000 is the amount we want her to get to. Not the time. It's not 10,000 years. That would be a lot of years. And we're going to divide by 3,000 to get the exponential by itself. We always want to get the exponential by itself. Here, these little zeros will cancel out. Hold on, I canceled out the wrong number. 1, 2, 3, 1, 2, 3. And so we get 10 thirds. So 10 thirds equals 1.05 to the t. You could also do it in a calculator. If you did, using a calculator, if you did 10,000 divided by 3,000, you would get 3.333. Now we got to be a little careful here because the next step is log base 1.05. So log base 1.05 of 10 thirds equals, that'll cancel out the 1.05 here. We just did log on both sides. It'll be t. So now I could type in math up log base 1.05 of 10 thirds, and this will get me the right answer. It'll be 24.677 years. This is the number of years. T is measured in years. And that's fine. Now, I want to point out that if you chose to use your calculator to divide this, then what you needed to do to get the right answer is press math up to get the log. It's still going to be log base 1.05. But you don't want to have it rounded. You want to put like 3.33. You want to go up and actually use this answer from before. So you press up until it highlights this answer and you press enter, and that'll get you the right answer again. Okay, so be careful with that. Make sure if you're rounding along the way, you're using the exact answer from up above. The same goes for like if you were doing something like this up above. If you decided to do natural log of 11 here and get a decimal, you don't round in the middle of the problem. Next, when you add 3, you would do 3 plus. You wouldn't round this. You would press up to highlight it, and that would keep the answer exact. And last, when you divide this answer by 2, you would go up to highlight it and divide this answer by 2. And that would get you the same answer as if you had just written it out exactly here. So I just want to point out that like you always want to go up and highlight the previous answer to make sure you're not rounding in the middle of a problem. You bought a car for $57,000. How long will it take to depreciate to 1/4 of its initial value if it loses its value at an annual rate of 22%? So write a function that will talk about the car's value over the years. Hopefully we realize the value of the car will be equal to its starting amount times it's losing its value at a rate of 22%. That's 1 minus 0.22 to the x, or 57,400 times 0.78 to the x. Okay, now we want to know when this value will be 1/4. It's going to 1/4 of its initial value. So they didn't tell us what that is, but we can calculate it. Oh man, you guys couldn't see it. 1/4 of its initial value is 1/4 times its initial value. That's 1/4 of its initial value. We know from elementary and middle school. So we want this value to end up being 14,350. And so let's solve this. Go ahead and solve it on your own. 14,350 divided by 57,400. I know this will come out to be 1/4, it turns out. It actually doesn't matter what the initial value of the car was. The answer will be the same no matter what. And now we're doing log base 0.78 on both sides. So log base 0.78, because that is the base of the exponential. So math up, log base 0.78 of 0.25, and it will tell us how long it will take. 5.57 years. Guys, and this is like 5.58. Notice that the next one would be a 0, and I didn't write the 0 because it's a 9, but the 5 comes after it and rounds up. Guys, this is about right that like it takes about 6 years for a car to go down to 1/4 of its initial value, depending on the car model. Models depreciate at different rates, but this isn't like super far off. So you buy a car for like $28,000, and 6 years later, you can sell it for $7,000. It's super crappy. Okay. The population of the United States can be modeled by this. How long until there are 500 million people? This is in millions. So 500, 1, 2, 3, 1, 2, 3, that's millions, equals, I don't know why I'm writing in red, 365, 1, 2, 3, 1, 2, 3, e to the 0.02t. Hopefully you were able to solve this by dividing, because here's our exponential. We're going to divide by 365 million, and it's going to be 500 over 365, whatever that is. The millions will cancel outright. And we get e to the 0.02t. Now, we need to cancel out this by doing a log on both sides. This is e, so we're going to do the natural log. So natural log will cancel it out. I'm going to do this in a calculator. Natural log of, you could have done this a couple different ways. You could have actually divided it in a calculator already and done this, but I'm doing it like this. So we get 0.3147 equals 0.02t. That's what was left over here. And now we need to divide by 0.02. Divide by 0.02, divide by 0.02. T equals, I'm going to take this answer and divide it by 0.02. I want to use that exact answer so I don't mess up my rounding. 15.736. We're going to round to 3 decimal places. 735, but the next number that comes after it is a 5.